Finally, we're going to look at hotspots because hotspots help us tell something about plate motions. So what are hotspots? Hotspots are places in the mantle that are warm enough to melt rock for a very long period of time. Therefore, they form volcanoes in the crust above, and because they stay in one place while the plate moves over them, they record plate movement. So if you're looking for a hotspot volcano, what might you look for? Well, you might look for one that is in a chain of other volcanoes, but is not associated with the subduction zone. Let's look at mantle plumes, which are what is responsible for hotspots. A mantle plume is a warm, rising material from the core to the surface that can sometimes erupt at the surface in one way or another. So in the first diagram here, you can see the rising mantle plume, and in the middle diagram, you can see that it is erupting as a very large and flat basaltic region called a flood basalt. There are a couple of places in the world where there are massive layers of basalt that formed in this way. But another possibility is that that hotspot will pop out a little volcano as the plate moves above it. And so rather than a very large area flooded with basalt, you'll have individual distinct volcanoes in a long line. This is a map of the world's hotspots, and look around and notice where they are and where they aren't. But where they aren't isn't very many places. Hotspots seem to be just about everywhere. They're in the middle of ocean basins. They are in the middle of continents. They are along mid-ocean ridges sometimes. Look at Iceland. Do you know where that is? It's in the upper right-hand corner of this map, right near Greenland, circled in pink and navy blue. Iceland is on the mid-ocean ridge, but it's also a hotspot. There are other places where there are hotspots along mid-ocean ridges. There's hotspots over in Africa where the triple junction is forming that we talked about the other day. We're going to focus our attention on two hotspots, but first Hawaii, which is right in the middle of this picture, circled in pink and circled in navy blue. Hawaii is a hotspot in the middle of the Pacific Ocean. So here is another view of the Pacific Ocean basin, and all of these triangles in red and orange are volcanoes, active or recently dormant volcanoes. I want you to notice a couple of things before we zero in on Hawaii. First of all, here along the west coast of North America are the Cascade Mountains, and up here in Alaska, along the Alaskan Peninsula, is a whole range of island volcanoes that form this long chain of mountains leaving Alaska and going towards the Eurasian continent. And notice this very deep trench along the Alaskan Peninsula. This is where the Pacific Plate is subducting underneath the North American Plate to the north and forming this long line of volcanoes. Also over here in the Western Pacific, here's the Mariana Trench that we looked at last time. So let's focus in Hawaii, right here in the very center. Hawaii is an island in a long chain of islands, and that chain is consistent in one direction for a very long time, and then it moves in another direction. So why would that be? What do you think caused that? There's a few clues to think about. One is that the island of Hawaii itself, which is way down here at the very end of this long chain, the island of Hawaii is the youngest island in this system, and the islands get older as you move away from Hawaii. Each island successively in the chain is older than the one before it. You're going to actually play around with the numbers and see if you can tell something about the movement of the Pacific Plate based on the ages of these volcanoes and the distance they are from each other. These are some pictures of Hawaiian volcanic eruptions. The volcano spews out a basaltic lava that forms two kinds of deposits. The one that this geologist is sitting on and pointing to is called pohoihoi, and it's a ropey kind of lava. The other lava that you see or the other rock that you see in Hawaii is a'a, and it's a very blocky rock that's quite sharp and hard to walk on. Now, Hawaii is the most well-known hotspot in our part of the world, but it's not the only one in the US. We have another hotspot, and it's over in the continent, this orange triangle right here. Anybody know where that is? That is Yellowstone. Our other hotspot in America is much more dangerous than Hawaii and much less likely to erupt in your lifetime. So let's look at the supervolcano that is Yellowstone. We'll compare it to Hawaii. So, of course, Hawaii is in the middle of an ocean and Yellowstone is in the middle of a continent. The crust is quite different. Yellowstone, as being on a continent, has a much thicker crust. The magma is quite different. The magma in Hawaii is basalt rock, very silica poor and thin, and it flows quite easily, whereas the magma under Yellowstone is silica rich and quite sticky, and therefore it's subject to a much more violent and explosive kind of eruption from Yellowstone. In both cases, you would see increased heat and earthquakes and venting, maybe steam coming out, as a warning that the volcano might be getting active. An eruption in Hawaii is pretty low to the ground. You might see a little fountain, but it wouldn't go up into the atmosphere, whereas an eruption at Yellowstone would send ash and gas very high into the atmosphere, and it would probably circle the globe if it was a big enough eruption. The ash and gas from Yellowstone will be deadly, and you won't be able to outrun it. This kind of volcanic hazard called a pyroclastic flow can be quite dangerous. Another kind of very rapidly moving volcanic hazard from this kind of volcano is a lahar, which is a mud flow, and those are also very difficult to outrun and quite dangerous, whereas in Hawaii, the lava moves relatively slowly. You can stay out of its way. Hawaii has been continuously erupting for about 200 years now. Yellowstone, on the other hand, has had 3 large eruptions in the past, one 2.1 million years ago, 1.2 million years ago, and 640,000 years ago. So the recurrence interval, 900,000 years, 560,000 years, and it's been 640,000 years. Yellowstone could erupt soon, or it could erupt 300,000 years from now, or it could erupt even longer from now than that. The chances of it erupting in the next 10,000 years is rated by geoscientists to be highly unlikely.